Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. Let me pause for a moment to tell you about our sponsor, Creative Safety Supply. Creative Safety Supply is a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor markings, it's all there. Download it for free at creativesafetysupply.com/5S. Okay, so then we're looking at measuring the variation. And we can do this 2 ways, range and standard deviation. I briefly introduced standard deviation, but not to this level. So range is a very simple number. It's the max minus the min. So you take the same data set, you find the largest value, 22, the smallest value, 1, you subtract the difference between the two, your range is 21. So the data points spread out 21 apart from each other at the extremes. So it's a very, very simple way of looking at how spread out the data is. It's a simple calculation, but you're also throwing away all the middle data points. You're not even using them. So it's a very rough estimate of the spread. So the standard deviation is a little bit more commonly used because it utilizes more of the data, kind of like the average does. So the standard deviation looks at the average difference of each value from the mean, and it measures how far apart the data points are from that average. And then basically does this squared value, and then you divide by the 1 minus the sample size. Sample size is n. Then you take the square root to get rid of the squaring. You end up with a number that is kind of like the typical distance away from the average. And the larger the number, that means the more spread out the data is. All right, so to actually do that calculation, if we took those 7 numbers, first we would calculate the average, which we did already. We got 9.43. And then we take the subtraction of the value from the mean. So in this one here, we've got 1 minus 9.43 is a negative 8.43 because it's 8.5 away from the average. And then we square that number and you get 71. And we do the same thing, 6 minus 9.43, 3.43 difference, square it, you get 11. 12 minus 9.43, 2.57, square it, you get 6.6. Here, this one, 22 minus 9, a difference of 12.5, square that, 158. That one is kind of looking almost like an outlier. Look how far off it is and what a large number that generates. So that will heavily influence this overall value. But then what you do is you add up these squared differences on the far right, and you get 255.7. You divide by 1 minus the sample size. We won't get into that in this class. It's like an adjustment factor for having smaller data sets. And you average that and you get 42.6. You take the square root of 42.6, you get 6.53. Roughly, the average of these differences, 6.43. But that's what that number represents, is a typical variation away from the average for each data point. So there's a lot more complication in that calculation. I won't make you do any of these by hand. Sometimes I do that with my classes for fun, but they don't find it very fun. So we have Excel and we have other programs that do this for us, but I just wanted to explain a little bit of background on it so you understand what the calculation is doing behind the scenes. So the good news is that the range is easy to calculate, but it's really only using 2 data points out of all that data. And so it's going to be less accurate. As the sample size gets bigger, it's going to become less useful. And it's going to be influenced by any outliers. So if I have one outlier, it's going to be either a min or a max. And so it's going to be affected by outliers. But unfortunately, so is the standard deviation. It's also influenced by outliers. And the calculation is more difficult, but it does use all the data values. So in most cases, we're going to use the standard deviation. The only time I've seen range used is in some of the examples where we have like 5 or 10 data points or less. So it can work okay when we have very small sample sizes. As the sample size get larger and we start dealing with 10, 20, 30 data points, then the standard deviation is going to be much more useful and helpful.
Lean6sigma-definition.com has a list of glossary items about popular process improvement terms, along with a history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ohno, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit Lean6sigma-definition.com.